Okay. This is... Oh, man, that's blurry. That's what that is. That is the link reaction. And now we're going in to this, just so you know. Okay, that is what we're doing. Today, we are learning the Krebs cycle. Woo! So, as you may know, in a cycle, you start with what you end with, because what comes around, goes around.
Oh,
Alright.
nice.
So, you start off with acetyl-CoA, which was the product of the link reaction. So, acetyl-CoA comes in and it goes hooking up with... Oop, well, that was a fail.
A really, really fancy chick from Europe named...
Oxalate!
Her parents hated her.
Clearly. And so, they have a little fun.
We should mention, how many carbons does this one have?
I don't know, you tell me, Megan.
This is 2 carbons.
Right?
And this is 4.
Right.
And you know what they form together? A 6-carbon molecule called...
Citric acid!
Woo! You know those juices and oranges you eat? Yeah, that's that.
Yep. It comes from the Krebs cycle.
This is how you get citric acid.
And then...
Because oranges are evil.
Yeah, it is. Citric acid is broken down into a 5-carbon compound, which we don't have to know the name of, thank God. And in this process, the 5-carbon, that 6-carbon that is clipped off right here, forms
Decarboxylation.
CO2. And the big word for this would be decarboxylation.
Oh, yeah, baby.
We exhale the CO2. Oh. Okay. The next step... Oh, wait, we can't forget.
You forgot something.
I forgot something.
Don't go forgetting stuff. I better keep track of you.
Energy is released from the 6-carbon. And so...
Because when you take a carbon away, that's oxidation. And oxidation gives off...
It turns into...
You didn't answer me.
You'll see.
But okay, yeah.
It becomes...
NADH because
it's reduced.
Oxidation gives off energy, electrons, and hydrogen ions, which are protons. This is a reoccurring theme. If you've watched the other videos, you should know this by now.
Exactly.
Just saying.
So, then, the 5-carbon compound is decarboxylated, leaving you with a 4-carbon compound, and this process produces enough energy for you to produce 1 ATP! Woo! Plus an NADH. Oh yeah. Yeah.
You know
Big
why we
step.
got that? Because of that. That's where we got that.
Exactly.
It's the same thing, just again.
So then we go over here.
Can we have a line, please?
A line.
Woo! Yay!
Beautiful. Alright, so then we come over here.
I'll move out of your way.
And this is the molecular rearrangement of our 4-carbon.
You remember back in alcohol... No, it was not alcoholic. But you remember back in lactic acid fermentation, where instead of becoming a 2-carbon molecule, the, was it pyruvate?
Yes.
Pyruvate was rearranged into lactic acid. Well, that's molecular rearrangement.
Yes. And in order to make this happen, there's a new coenzyme.
Nah, it's just a fad.
As you will see. See what we did there.
Okay.
And...
It needs a plus, ma'am.
Okay. The fad.
It's a positive fad, unlike the, like the bands or the drugs and stuff.
It is
a good one.
a Christian one.
It's a good Christian fad.
And then it converts, it's reduced to FADH2.
Ooh.
Then, also eventually, it goes on that NAD plus is reduced to
NADH, as you can see happens a billion times in this.
Yeah, there's a glare. Okay, now you see the two little floating eyeballs above it.
Yep. And so then, making sure that we did not forget anything, this eventually comes back to our beautiful little child who was sadly misnamed as oxalitate. Goodness, that's hard to say.
Yes.
Try saying that.
So basically, you're telling me aerobic respiration is the sad love story of a teenage romance.
It is! Oxalitate is left all by her lonesome after having all of these children.
And you know what? She has so many boyfriends, because this happens so many times that it'll hurt your brain to think about it.
It happens 10 million times per cell per second.
Ow.
Yeah.
My brain just blew up.
Exactly.
And you know what the point of this? Speaking of explosions, the point of this is to slowly take energy away, to get a little burst of energy at a time. If not, say they converted it and just made all these ATP at the same time, the cell would explode. And I know that'd be cool to watch, but we'd all die.
Sure would.
So,
alright.
Final products.
Final products is 2...
We forgot something.
ATP. No, I didn't.
You didn't write the ATP or ADP in the reaction.
I did.
Oh, there's one.
Because, let me back up. This has happened twice.
Excuse me. I am wrong. Let's do this.
It has to happen twice in order, because there is 2 glucose molecules made in glycolysis. So, of course, it has to happen twice.
No, there are 2 pyruvate.
I'm sorry, I meant that.
Sorry.
It has to happen twice because it can only take one pyruvate at a time.
I mean, oxalitate dates a lot, but she's not a hoe.
Exactly. So anyways, there's 2, the products are doubled, so it's 2 ATP, 8 NADH,
Woo.
2 FADH2, and 6 CO2. Alright, yes. So, what Megan is chanting over there. Okay, so oxalitate, you know, Asio Koei was trying to get back with oxalitate, and she was like, it's too late to apologize.
And then there's a dirty joke we can't sell you.
2826,
2826, 2826, 2826.
So, I'll let you think on that. And here is Krebs cycle. Come back for electron transport chain.
Woo! It's so long!